Good morning, class 12. Now in this lecture we will complete the valence bond theory. And the valence bond theory is very important topic in coordination compound, because with the help of valence bond theory we can get some idea about the bonding between central metal atom and the ligand molecules. So it is very important theory. So from the beginning, the formation of a complex is a reaction between a Lewis base and a Lewis acid, resulting in the formation of a coordinate bond between ligands and a metal. So in the complex compounds there are two species, the metal and the ligands, and there should be some interaction between them, and then interaction between a covalent. According to VVT, the interaction between the central metal atom and the ligands is a covalent interaction, and in this central metal atom behaves like a Lewis acid, and the ligand behaves as a Lewis base. Why they can act as a Lewis base in the case of ligands? So we know that that the ligands species can donate at least one lone pair of electron. That's why they can behave as Lewis base, because Lewis base are those species which can donate at least one lone pair of electron. Lewis base means lone pair donor, and in the case of coordination compound, the central metal atom or ion, it is accepting the lone pair of electron from the ligands. That's why it is behaving like Lewis acid. Lewis acid. Okay, one second. This side there should be Lewis acid, not base. Okay, so central metal atom or ion behaves as a Lewis acid. Why? Because they are acceptor. They can accept the lone pair of electron from ligands molecule. Now we will start the postulates. So the first postulate is, in the complex compound, the central metal atom, they can provide the vacant d orbital or vacant, they can provide any of orbital, maybe P, maybe S, maybe P, maybe D. Especially they have the D orbital, because the central metal atom belongs from transition element, or we can say that D block element. So it is a speciality of the central metal atom to have vacant d orbital. So according to first postulate, the central metal atom or ion, the metals provide a vacant d orbital uh, to a ligand, so that ligand can donate its lone pair of electron to central metal atom or ion. So in the first postulate we can understand that there is some bonding between metal and ligand. And what is metal doing? Metal is accepting the lone pair of electron from the ligand to provide a definite number of vacant d orbital. Okay, now second, vacant atomic orbital of central metal atom or ion, according to the requirements, undergoes a certain types of hybridization. Means during the lone pair accepting time, means if the lone pair will be donated to central metal atom, then there should be a hybridization bit for the metal. Means according to the requirement, the central metal atom undergoes a certain types of hybridization. For example, suppose the coordination number of the coordinate of a coordinate compound is 4. For example, there is a ML4 N plus minus type coordination compound. M central metal atom, L the ligands, and there are the 4 number of ligands, and N may be a charge. It may be plus positive, it may be negative. So in the case of coordination number 4, the hybridization will be sp3 and the shape will be tetrahedral. So according to the requirement, if the 4 ligands are approaching, then then the shape will be tetrahedral. Why the shape will be tetrahedral? Because the hybridization will be sp3. sp3 means total 4 digits are there, 1s and 3p. sp3 as 1s and 3p, that means sp3 hybridized orbital in the case of central metal atom. So according to the requirement means the total number of ligands molecule which are approaching to the central metal atom or ion. So according to the requirement, the central metal atom undergoes a certain type of hybridization. For example, in the case of 4, the central metal atom undergo sp3 hybridization. And if the six ligands are approaching means the coordination number is 6. So the hybridization will be sp3d2 and the shape will be octahedral. So according to the requirement, it will decide what to do, at which type of hybridization it can show. It will be according to the number of the ligands molecule or the ligand species, and according to the coordination number. And coordination number is simply depend upon the number of ligands molecule. Okay, so this is the second postulate. Now third postulate is very simple. It will show the bonding between the ligands and the central metal atom. So according to the third postulate, there's some overlapping occurs between the participating participating atomic orbital of metals and the ligands. Means there should be some bonding between central metal atom orbital and the atomic orbital of the participating ligands. So we have already I have already defined that there's some overlapping between these atomic orbital between the central metal atom or the ligand. That's why it is a covalent bonding between them. So both orbital, they overlap each other to form a coordinate compound. Okay, so there should be some bonding between them. Now the fourth postulates non-bonding electrons of the central metal atom or ion remains unaffected. Means if the electrons are non-bonding, that means the non-bonding electron means the electronic cloud which are not taking part in a bonding, so they will remain unaffected. So there's no any extra things to be clear to define. It is so simple. Now fifth point, during the complex formation, Hume's rule of the maximum multiplicities is strictly followed. Means we know that about the Hume's rule, we have already completed in 11th class. So but this rule cannot be followed in the case of strong ligands. And what are the strong ligands? There are the 2 or 3 or 4 types of strong ligands, but these two are very important. And CO and CN, CO carbon monoxide and cyanide, they both are strong ligands. So this thing we will clear in the upcoming lecture when we will start the bonding of the complex compound. Then this postulates will be needed, and we will follow this postulates. So then this time it should not be so clear, I think so, but for the upcoming lecture it will definitely will be clear. Okay, by showing the example of the complex compound. Now sixth point, if the free electron is present in the orbital of central metal atom or ion, if there's some free electron present in the central metal atom or ion, then the compound, that particular complex will be paramagnetic. Means in a coordination complex there is a ligand and a metal, and if the metal having a free electron in its orbital, then the complex will be paramagnetic. And we know that what is the paramagnetic character? Paramagnetism means a compound, if the compound is situated in between the two poles, north and the south, or we can say that in the presence of magnetic field, the compound may be attract towards the magnetic field. So it will be the paramagnetic character. So what is the main condition for having the paramagnetism by the complexes? So the central metal atom must possess a free electron which is not taking part in the reaction, or we can say that the free electron available in the vacant d orbital. And if the electron is not present, so the complex will be diamagnetic. Means it will show the diamagnetism. It cannot be attracted towards the north and the south pole, or in the presence of magnetic field. So these are the concept and the postulates of the VVT, and in the next lecture we will complete the bonding and hybridization and the paramagnetic and the diamagnetic magnetic characters of the complex compound. So the VVT postulates are very important. You have to complete it, and definitely you can make the notes of it. Okay, so thank you so much.